Hi, everyone. Thank you very much for joining us today and welcome to this RISE session. My name's Sophie Norton. I'm a senior consultant at Turner & Townsend, and I have nearly 20 years experience of working in the heritage construction sector and have done a little bit of work in retrofit. So I'm here as your host, but our real expert here today is John Edwards. John and I have known each other for quite a long time. And I think of him as a real expert in heritage retrofit specifically, but he's going to give a bit more detail about his background in a few moments. So that's John and I. So I think that's all the information that I have to convey to you. Welcome once again. Really happy to see you here. Over to John to introduce himself and start his presentation. Thank you, John.
Great. Thank you, Sophie. If I can just tell you a little bit about myself. When I left school, I worked on construction sites as a tradesman. And because it was 1976 and every day was like today, very hot, I decided to progress into other things. And since that time, I've been heavily involved in all sorts of things to existing buildings, including building conservation and including retrofit. For the last 10 years, I've been a director of Edward Hart Consultants. And prior to that, I worked for CADU as the director responsible for managing their estate. Before that, I worked for English Heritage, where I saw an awful lot of Sophie at that time, many, many years ago. And today, I do also deliver a lot of training in this area. And I have a part-time professor role at the University of Wales in Swansea. So a lot of time delivering projects and analysing buildings, but also delivering training, and I've spent a lot of time developing standards as well. I've been involved in the development of all the latest BSI standards on retrofit, PAS 2035, PAS 2030, PAS 2038, and I'm also the lead author of BS 7913, which is the British standard for building conservation. Anyway, that's enough of me. Today, it is a very short session and it's a very big subject, so we'll do the best we can to cover it as well as we can in the time that we've got. I wanted to actually show you a couple of case studies, but in putting all this together, I realised that we really do need to understand the basics first. We need to understand the guidance and the standards we're working to, and then we can start understanding how we put all that into practice, which is what we're going to try and do today. So the first thing we need to do is understand the basics of what this is all about. So the very basic thing that everybody needs to understand is the basic difference between a traditional building and a modern building. If we don't know that, then everything else is going to be wrong. So in very basic terms, on the right-hand side, we have an illustration of a section through a traditional building, a typical traditional building with solid vapor permeable walls and a solid vapor permeable floor. So when it rains on the outside, the moisture, the rainfall will soak into the building fabric through the external face of these enclosing walls. And when the rain stops and the sun comes out, most of that moisture will evaporate via the external face of those enclosing walls. But some of it may evaporate internally in a very equal way and a very minor way. I'm talking about vapor, liquid as a gas, may evaporate through the internal face of the enclosing walls and also through the surface of the floors, I say in a very minor way. And any moisture that does accumulate within the internal spaces of the traditional building will disperse into the atmosphere through natural ventilation because we have open chimney flues, windows that don't quite fit and the like. And that is the way traditional buildings have been functioning and performing for many, many hundreds, if not more years, until we start treating these buildings as if they are modern, and that's when it all goes wrong. And if we compare the traditional building with the modern building, comprising building fabric which to varying degrees is vapor impermeable and relying upon air gaps, cavities or vapor barriers in the external building envelope to keep the moisture out, and at least in some spaces relying upon mechanical ventilation to remove moisture that does accumulate, we can see that these buildings are different. They perform differently and they should be treated differently. Now, the problem we've got is that we treat many traditional buildings, well, I would say this, I'll come off the fence and say that in the thousands of buildings I've been to over the last 40 years, I would say nearly all traditional buildings I go into, unless they have some kind of special protection, are being treated as if they are modern. Why is that the case? Is it the case that we don't really understand what we're doing and we're like sheep and we follow everybody else? I don't know what it is. Maybe it's because we've treated traditional buildings as if it's a niche area. Well, we normally categorize a traditional building as a building built before 1919. And if we look at the stats, nearly a quarter of all UK buildings were built before 1919. So 25% of our building stock is not really a niche, is it? And that 1919 date is very much misguides us because there are a lot more traditional buildings around over and above those built before 1919. And if we look at the definition of a traditional building, and you can read it here as it appears in the latest edition of PAS 2035, you relate that to some data from the BRE, the Buildings Research Establishment, and if you also remember the Department for Energy and Climate Change, on their website at the beginning of 2015, it stated approximately 35% of UK dwellings are of traditional construction. So we're talking about a third. These are far too many to be a niche. So we should understand them a lot better, but it also indicates something else, doesn't it? We're at that stage in time now where we will be tackling a lot of these traditional buildings, and we need to do it properly. And very often we don't treat older buildings properly. So if we look at the image on the right-hand side, that castle there, 19th century castle, a grade 1 listed, a scheduled monument. When it comes to repointing the mortar joints, the exterior masonry mortar joints, we'll have the most specialist, skilled people repointing those mortar joints, going through the right processes, the right tools, the right materials, done in the right way. Do a great job. Lime mortar, of course. And if we compare that with the way we treat an ordinary, everyday, bog standard, traditional building, which doesn't have any special protection, you can guess, as a norm, we do not treat the mortar joints the same as we do with the castle. In fact, we'll most certainly use the wrong materials. We'll most certainly use cement. And that is a typical way in which we'll treat that ordinary, everyday, traditional building. But it shouldn't be that way. These buildings should be treated the same, but we treat them differently. That's not good, is it? But that's the typical way in which our construction industry works. And if we look at the way in which the mainstream building industry treats the modern building of the day and the old traditional building of yesterday, then we treat these buildings the same when it should be different. And this all stems from the fact that we don't understand buildings properly, and we most certainly do not understand traditional buildings. And we need to understand buildings better, so we can understand the difference between traditional buildings and modern buildings, which is an essential foundation for going forward with. But then again, what is an historic building? Well, I've already spelled out the similarities between these two different buildings here. And you can see that on the left-hand side in the bullet points. But there's one bullet point right at the very beginning, which indicates what the difference is. Because all buildings, all traditional buildings, by the very fact they've been around for a long time, could have some capacity for being significant. And when we say significant, it means they have some capacity for having heritage values worth noting. Now, where the castle is concerned, they'll have a massive amount of significance, and the little terraced house may have less. But that's the difference. That, you could say, is the difference between a ordinary, everyday, traditional building and one that's protected, because the one that's protected may have higher heritage values, but very often, technically, they're the same. But let's look at a definition of a protected building, again from PAS 2035, and you can read the words there in front of you. So if we want to understand exactly what all these different categories are, if we look in PAS 2035 or we look in PAS 2038, we'll see what those definitions are, and they're very easy and straightforward to understand, and that's something that should be guiding us. But what does retrofit mean? Now, I like looking at dictionaries to see what words mean. And if we look in a dictionary, that word retrofit means add to something did not have it when it was manufactured. And I can turn that into what building retrofit means. And building retrofit means adding something to a building that did not have it when it was constructed. Now, I know many people, many organizations will embellish this word into meaning something else. But the one thing I've noted in looking at all these various different definitions, they're all different. And sometimes we leave important things out. So I always stick to the raw reasons what a word means. And if you look in this British standard, it will tell you what that means. Let's look at guidance and standards. So when we're working on retrofit, we work to standards and guidance, or we should be. And we know that the mainstream document for dwelling retrofit is PAS 2035, which is largely the process with some elements of standards, principles, and competency and qualification requirements. And the implementation part of that process is PAS 2030, which has got, apart from the few pages at the front, it's got dozens of appendices, each one indicating everything you should know about each particular retrofit measure. Where traditional buildings are concerned, we have PAS 2030, so we have BS 7913. BS 7913 doesn't contain a process as such for retrofit because it's there to do with everything to do with existing buildings. But I turned BS 7913 into a retrofit process when I drafted the IHBC guidance, the Institute for Historic Building Conservation guidance on retrofitting buildings. And these standards are very important. And because each of these standards, and there's a great many more standards and guidance out there than these, what you see in front of you, a great many more, as a lot of people know who've seen my presentations before, they do determine the outcome of your retrofit project, and they do determine how suitable your retrofit project is for the building in question. Now, just to emphasize the point, and we haven't got time to look at each and every single stage of this process here taken within PAS 2035, but what I want to indicate to you is what I've just said. Basically, when we're implementing PAS 2035, we implement also PAS 2030, and most importantly, we should not forget BS 7913. In many different ways, not just in terms of significance assessments, but for the other important pieces of knowledge it will give you. Now, again, this is the process. Well, it's a summary of the process you see in PAS 2035. And we've got a process on the left-hand side where it shows all buildings. And then you've got all these other different categories there. Anyway, it's written in a different way in which you'll see in the document itself. But you should note there are additional qualification requirements within PAS 2035. So most roles require a level 3 award qualification, unless you're a designer and you are conservation accredited or certified. We need to do significance assessments, and where protected buildings are concerned, that is in accordance with BS 7913. If it's not a protected building, then it will be in accordance with Annex E of PAS 2035. And a slide which isn't showing you today, but we also have a British standard at the moment, BS 4104, which is the British standard for retrofit assessment. And watch out for that one. It's out for consultation at the moment, because as far as the simplified significance analysis is concerned, it delivers exactly what Annex E of PAS 2035 does, but in a simpler way. So watch out for that one. And of course, the other thing that PAS 2035 requires is heritage impact assessments. And I'm going to show you a heritage impact assessment later. Now, this is a process I developed when I turned BS 7913 into a retrofit process for the IHBC. And it takes you through the very logical stages that we need to go through in order to successfully retrofit a building. And when I say retrofit a building, I just don't mean retrofit, because there's lots of other things we can do to older traditional buildings and modern buildings as well, as it comes to it, which will improve their energy performance, will improve their resilience to the effects of climate change, but will not necessarily improve the ratings, the energy ratings. And we'll come back to that in a moment, but another document that's very good, I would say, is BSEN 16883, which is basically the European standard for retrofitting historic buildings. I've used I've used this document on a number of buildings. I'm using it right now. It's a good document. I would like to show you table 1 of this particular document, but I don't think it, yes, we are, table 1, because table 1 gives the document its authoritative status. So just sit back and look at this slide. Look at all these words on the screen. And when you are assessing your traditional building or your protected building or your historic building, whatever you want to call it, you will be assessing your building against every single word that you see in front of you. It's a very comprehensive document. It's got a great authoritative status, even though many people haven't heard of it. But I find it very useful to take a project through this if you want to do it properly, and if you want to get consent to actually retrofit historic buildings. I say this is a good document. But let's look at the general approach for all these different documents where traditional buildings and historic buildings are concerned. So when we're looking at BS 7913 in the top left-hand corner, it expresses a whole building approach and a risk-based approach to retrofit, not fabric first, a risk-based approach. If we look at the European standard, BSEN 16883, it's the same. If we look at PAS 2035, if you read PAS 2035, the 2023 version, you will say it starts off by saying always fabric first, and then it's got a few caveats by saying put the building fabric into good repair, which is totally sensible. Then it says do the low-hanging fruit. Then it talks about replacing distressed boilers and heating installations and such like. I'm simplifying all this for the sake of speed. And then it says fabric first. But what it also says is that where traditionally constructed buildings are concerned, it says a risk-based approach will usually be more appropriate. Now, it also expresses a whole building approach, and I, like some other people, can't really get my head around a whole building approach, which is a risk-based approach, and a fabric-first approach. And if you look at the Trustmark website, it actually got two different bullet points to say, this is what fabric first is, this is what whole building means. So, watch out for that one. But there are not that many standards and guidance that says fabric first. If you look at them all, like PAS 2038 doesn't mention fabric first. The RICS guidance, new retrofit standard, expresses concerns about fabric first. The UK Green Building Council says it shouldn't be fabric first all of the time. So we've got to get up to speed with all of this. And where I've already mentioned PAS 2038, it's a risk-based approach that's recommended. So the general approach is slightly different when you're working to PAS 2035, but then again it isn't, because it, as I said, where traditional buildings are concerned, it says take that risk-based approach. So now you know what you got to do. So let me show you an example of how we would put this into practice on one of my latest projects. So it is this place here on the South Wales coast in Swansea, where my university is located. That is just a pure coincidence, I would say. And we're obviously utilising BS 7913 when we are developing this project. Because the first thing we have to do is a listed building, a Grade 2 listed building. It's a Georgian terrace, Grade 2 listed. And the first thing we need to do is assess the significance of the building. And you've got to do it properly. If you don't do it properly, you're not going to get consent for the work. So if we have a look at this building, you can see what the front is like. It's a masonry building. The front elevation has a brick face on it. The rear elevation, the side elevation, has rendered faces, but it's gone through a lot of alterations over a period of time. And also the rear has a cement render, the side has a cement render. Part of our process in analysing significance, and I'm really shortening what this process is all about in a major way when I'm saying all this, but one of the key things we need to understand is the chronological changes which are taking place in the building. That's one of the things we need to understand amongst many other things. And we can map that out in narratives, and here we're looking at it on plan, and we'll have all the various different floors. I'm just showing you one. So what we're indicating here is areas in red is original construction. Areas not in red is not original. Okay, that helps us analyze our significance. But like I said, we need to know an awful lot more than that, an awful lot more. And then ultimately, when we're analyzing significance, and once we've determined significance, we then map out what those levels of significance are. We do that in narratives, and we also do it on plan and elevation forms as well. So when you're looking at the plan form, it's telling you what the levels of significance are. And what that means is we're looking for scope for change. If we have to make changes to a building, there's much greater scope for change if you're in orange, yellow, or green. A much more difficult scope for change to justify where we're affecting things in red. It's not to say we're not going to be able to touch anything in red, but we've got to try an awful lot harder. So what this does it gives a framework for the architect to work work, the architect knows what objectives we need to achieve, and the architect working with the project team will work out the best way in order to achieve those objectives. And of course, as we're going along the way, understanding the relative significance of each part of the building helps the architect develop the optimum proposals. So that is the first stage of that process, the significance analysis. The second stage of the process is understanding everything else about the building, its construction, its materials, the use of the building, how the use has changed, how changes of the building have taken place, its condition, and lots of other things as well, which you can see on the screen in front of you. Properly understanding that building in all respects is critically important. Then we've got the energy efficiency assessment and modelling, and where many dwellings are concerned, many dwellings that I've looked at when I've been scrutinising projects which have been completed, we're very often using the very basic energy modelling software, if you can call it modelling, and that's RDSAP. And that will give you the recommendations on what measures should be installed into the building in order to improve its performance and improve its rating. But we have to go an awful lot further than that. This is a listed building, and when we're looking at the measures we want to install, we're taking a risk-based approach. But because we need to properly understand how this building is performing right now, we have to properly understand the U values. We have to do in situ U value tests. We have to take materials out to the wall, get them tested by a material scientist, recalculate the U values, do some hydrothermal modelling, also using all that material data and also local predicted weather data, and then we can model this building how it's performing right now and into the future. So at this particular stage, hydrothermal modelling is part of that picture. And then at stage 4, we're taking all the very good information from stage 1 on significance, all the excellent information from stage 2, the retrofit assessment. We're looking at all the good information from stage 3, which includes that list of energy efficiency measures that the modelling is recommending. They go into stage 4, and at stage 4, with all that information at hand, we are looking at feasible objectives to achieve, not just energy rating objectives, not just energy performance objectives, lots of different objectives and the way we want to improve this building. And as we're doing that, we'll then set our targets of what we want to achieve, and then we work out the best way of achieving those particular targets. That's a stage 4. And then, let's continue with stage 4. Just briefly mention this. Many of you will probably recognize the image on the right-hand side, the measure interaction matrix taken from PAS 2030 and PAS 2035. It's a great starting point when we're looking at the measures we may want to install, because if you end up on a red box when they coincide with each other, then you know you're not going to be able to do those measures. If you end up on a green box, great, you can just crack on with it. If you end up on an orange box, you've got a lot of thinking to do. And if you end up on a yellow box, then you've got to draw construction details. I'm hugely simplifying all this for the sake of speed. It's a good starting point in a way you may be excluding some of the measures you may want to install. But we also have to remember that a lot of energy modelling doesn't properly understand the impact that the measures are going to have on the building and the impact that the measures will have on each other. And that's where the measure interaction matrix comes in. But you can also use this guidance wheel. And this guidance wheel is really good, I would say, created by the Sustainable Traditional Buildings Alliance. Okay, I got a little bit of a vested interest, tiny. I'm a board member. I don't get any money out of it, so don't worry about that. But it's a good online tool. So when you've decided, for example, here you want to install some internal wall insulation, arrows spring out to other things you've also got to consider. And then once you're considering those other things, you put your cursor on those other things and other arrows will spring out. And it will take you through the whole building retrofit process. By doing this properly, following the links, looking at all the different risks, all the benefits, it can really help you develop a whole building approach, which I will say almost always will go over and above the measures which have been recommended by the modelling, because this is going to take you to safe retrofit. Okay, we've done stage 4, now at stage 5. Stage 5 is the heritage impact assessments. So really speaking, even at stage 4, we're doing heritage impact assessments, but we've got to formally produce them. And the reason why we have to formally produce them is twofold, really. One is we got to make sure we're doing things properly. And the other reason is that we need to get consent for this work, and you need to demonstrate and evidence that what you're proposing to do is the best thing you need to do to this building compared to other alternative courses of action. So as we're contemplating heritage impact assessments, there's a thought process we need to go through. First of all, why are we doing all this? Why are we doing this particular measure? Well, obviously, we want to improve the performance of the building from an energy point of view, make the building more sustainable, blah, 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 all those sort of things. We come to number 2, but is it really necessary to do this particular thing to the building in order to achieve these objectives? Number 3, what about alternatives? Have we looked at all the alternatives to see if they are better than the option we're looking at right now? And once we're going through this process, we also got to think about what the impact on significance is of any choice we're actually looking at. And we also got to consider then, within the heritage impact assessment, whether we can actually mitigate any negative impact on significance, and if so, how can we do it? And that's the thought process we go through. Now, this may be a bit difficult to read if you've got a very small screen. That's okay. There's only one slide there. Right, okay. So I'm just going to show you an example of a heritage impact assessment that we would prepare for a building that has special importance, a listed building in this particular case here. And this complies with BS 7913, but I've put in a couple of additional columns because I think it's the right thing to do. So this heritage impact assessment is to replace the cement-based render on the side and rear elevation of this particular Georgian terrace. So the first column we've got is proposal and location. Then we detail why we want to do it. And then we say about the problems with the existing cement render. They're cracked, they let in water, they trap moisture in the wall. And we also say that the original render would have been a lime-based render. And we say any solid wall insulation will improve performance, but in the form of a lime render, it will also improve moisture performance. And then underneath that, we say the assessment of existing new values along with hydrothermal modelling suggests that the wall should be insulated. Furthermore, its necessity in providing improved thermal performance is highlighted in the whole building assessment, which has indicated an optimum range of work with due consideration of the impact on the building and the impact that measures have on each other. So, I just emphasize the point here. We've taken a risk-based approach, but we're doing fabric improvements. So when you're taking a risk-based approach, doesn't mean to say you're not going to do fabric improvements. It's just you're going to go through a certain process that takes you towards what you should really be doing. And then we got the next column. We detail in what the significance is. You can read that, can't you? Yeah, we detail what the significance is. Then we got an additional column I put in, which is over and above what you see required in BS 7913. And that is a section that gives people references to other pieces of evidence, if you like, or other documents that they can refer to when they're actually looking at this heritage impact assessment. Again, there are 2 reasons for this. When we're undertaking any work like this, it's not just about recording the work we've done, but it's recording our decision-making processes, because then we can learn from our decisions today going forward into the future, especially when we look back into the past of what we did and how we made those decisions. So this joins up all these documents together. But the other reason for putting that particular column in is because whoever's reading this, and it will be a conservation officer, and it may be the heritage body as well, at least they can refer to these sections or these other documents to see exactly what we mean. And then in the next column, we got the impact on significance, and you can see what that says there. And then we've got another column called mitigation, and you can see what we say there. The insulated render must be designed in such a way as to minimize risks of thermal bridging, and therefore the design at the interfaces with other insulation must ensure that thermal bridging is eradicated. Ensure careful detailing overall. The render must be taken down to the ground to minimize thermal bridging risk at the base of the wall and protected by a roof overhang at the eaves. Okay, we're going to extend the roof over to protect the insulation. But to be honest, that was the original design of the roof. So we're reinstating it, but we're referring to another heritage impact assessment which addresses that particular issue. And then the second column under mitigation, we say the assessment U values and the hydrothermal modelling is based upon published material data and not real data gathered from in situ construction and materials present. In order to fully understand the existing and improved thermal and moisture performance, material testing and in situ U-value tests should be undertaken. See HIA, Heritage Impact Assessment R. And that's because we haven't done all that material testing at this stage. We ran out of time. We wanted to get a consent application in, but we're highlighting it in an open and transparent way exactly what the situation is here. So then we got another column then, other options we considered and rejected. And again, this is an additional column that I put into my heritage impact assessments. So one of the options is leaving it as it is. But we're saying this is not feasible because the building will deteriorate and with the continuous moisture ingression and obviously stopping the drying out of the walls. We also look at repairing existing cracks, but we say the cement render is incompatible with the building fabric and will continue to crack, so this is not a sustainable solution. Then we took another option then, which is apply a line render, which is not insulated. We say this will mean that the objectives of improving energy performance will not be achieved, which means not achieving the energy rating targets demanded. Okay, and then we got installing a board-based external wall insulation system would only be feasible if it was of a vapor permeable kind. However, whilst this is perfectly feasible, it doesn't provide the same degree of compatibility with the existing fabric as a line render, or provide the same natural finish as it would be perfectly flat. Plus, a thickness of 120 millimeters is required, which will have too much impact on aesthetic significance. So we say insulating the walls to the rear and side externally means that they do not have to be insulated internally, thus maintaining the benefits of thermal mass and not requiring a reduction in room sizes and the associated work that would have to be undertaken with internal wall insulation. So, we squared up to the other alternatives there. And then we got the conclusion. We say there, it is a necessity to remove the cement-based render and replace with a line-based one, which will reinstate the original moisture performance characteristics of the building. And the last paragraph is very important because it tells you exactly what the situation is. We say, considering the need to improve thermal performance, it is concluded that this is necessary and that overall an insulated render has superior compatibility compared to a board system. However, further material testing and in situ U-value tests should be undertaken to mitigate all risks. So we've got listed building consent to do this on the basis that we do this other work, which I think is fair, because this other work is necessary in order for us to understand exactly what we should be doing and not to take risks. So then we are at the stage when we're finalising our proposals and we're designing and specifying the work. And after that, we'll implement the work. Now, another important point I want to make. Buildings need to be in good condition if you're going to retrofit them. You can look at all sorts of words in the likes of BS 7913, which says damp building fabric can be over a third less energy efficient. And that is so true. I got data to show that anyway, with in situ U-value tests and moisture tests in building fabric of the same building. So it's true. We need buildings in good repair. But going back specifically to this particular project here, the hydrothermal modelling assumes that the walls are in good condition. Now, if you look at the right-hand image, you will see a lot of the bricks are crumbling on the surface, yeah? And that might be okay from a building conservation perspective because we practice what we call minimum intervention, which means executing a proper repair, but doing no more work than that. And that could mean, consolidating some bricks or just stressing them so they're not going to hold any moisture. And then we may go back in 20 years' time when the brick has deteriorated more, and then we replace it. That is where there is a potential conflict with building conservation because the hydrothermal modelling assumes that the walls are in good condition. And that means we should be replacing existing bricks with new bricks, matching existing. We should be taking a very conscientious approach to repointing mortar joints. So forget about the pointing trowel. Forget that. You need a pointing iron. Okay, yeah, good luck in persuading all the contractors you may want to engage who've always been using pointing trowels. But if you go to Historic England and ask them what the right tool is, they will tell you it's a pointing iron, which is true. And so that is the way in which you'll do a robust job. And what this means here as well, is also doing some grouting, micro grouting behind bricks where there's voids, because this wall needs to be in good condition. If it's not in good condition, with the installation of internal wall insulation, there'll be two things which are going to happen. One is it will contribute to a performance gap, the gap between the performance we thought we were going to get and the performance we do get. And the other issue is it creates a moisture risk. Okay, so we need to be very conscientious about the way we treat the original building fabric as well. And then we don't always have an audit, but we always have a post-occupancy evaluation. The post-occupancy evaluation is there to see whether we've achieved the objectives. I personally don't believe the PAS 2035 is good enough in that particular area. And an audit is to see whether the work that was supposed to have been done has been done and whether it's been done properly. I just want to make the point that if you take the right approach, with the right team of people around you, you stand a good old chance of getting consent for work that some people might say, you never get consent for that. So the two images here, okay, one of them is not a real image, but if on the left-hand side, you can't see any PV panels on the roof, can you? On the left-hand side. On the right-hand side, can you see the PV panels on the roof? Not really, not from this angle, not from this distance. So let's have a closer look. Left-hand side, you can't see any because there aren't any. Right-hand side, yeah, if you look for them, you'll see them. And this is the consent we've got to put PV panels on the front elevation on the front roof of the main elevation of the building. We looked at all the other alternatives. First of all, we look at why we need to have PV panels, and then we look at all the various different panels we can install, and then we look at the location which we can install them, and we ended up with this because we excluded all the other locations and types until we get to this. But that is well explained in our application. And let's have a conclusion. Let's have a conclusion for the next couple of minutes. First of all, the QR code will take you to information about item number 10, the level 3 award qualification, and that's the qualification you need if you are going to work to PAS 2038 or PAS 2035. Look in the document for the detail, but that's what it says. And if we look at item number 1, I would say we should always adopt the right approach and apply the right principles. Get people to trust you that you know what you're doing, and you'll go a long way. You've got to build the right team, the right approach, with the right knowledge set, the right expertise to get people to trust you. That's number 1. Number 2, we need to take a risk-based whole building approach all the time. Number 3, note that traditional buildings are different to modern. That should be the starting point. If you don't know that, then everything else you're going to be doing is going to be wrong. And that's one of the flaws that we have in many people's knowledge, I think, that they think that the difference between a traditional building and a modern building is just those heritage values and that significance. And that is not the case at all. Technically, the buildings are very different. Number 4, work to appropriate standards and guidance. Number 5, work to BS 7913 and where appropriate, BSEN 16883. It works for me. Number 6, be cautious about any certified product and BBA certificates. Be cautious. Have a look at them critically. If it's for insulation, have a look at the materials. Are those materials suitable for a traditional building? Are they really suitable? Look at them in detail. Build up your knowledge set to understand exactly what these materials are and how they function, and then decide whether to install it. Even if it is within the BBA certificate, it may not be suitable for the building. 7, be cautious about building regulations. Quite honestly, we all know building regulations basically being developed for new construction. And when you look at, I'll go back to the BBA certificates. When you look at BBA certificates, it tells you how all these products, they comply with building regulations. Sometimes the building regulations are not really good enough for older buildings, I'm afraid. Number 8, appoint expertise. If you're a client, appoint people who are experts, not people who've got no expertise, but they've just done a short course. That doesn't make you an expert. Number 9, training and qualifications. So if you are going to be trained in this particular area, ask who the trainer is. See what expertise they've got. Have they demonstrated their expertise to people who have independently assessed them? For example, look for a trainer who's conservation accredited or certified. And I've already mentioned number 10.